Hello viewers, in today's session we are going to discuss an important problem from differentiability of functions, right? So here we are going to discuss the derivability or differentiability of this function f of x that is given by e raised to absolute value of x minus 1, and we have to check the differentiability of this function at this point, that is x is equal to 1. So we have to see whether this function has a derivative at x is equal to 1 or not, right? So for checking the differentiability of a function at a given point, we have to find out the right hand derivative and the left hand derivative, right? And if the right hand derivative and the left hand derivative both exist and they are finite and they are equal, then we can claim that the function is differentiable, right? So let us first find out the right hand derivative and the left hand derivative of this function at x is equal to 1, and then we'll draw the conclusion regarding the differentiability of this function at x is equal to 1, right? So let us start. So now let us define the right hand derivative by this limit. That is, the right hand derivative is given by limit h tends to 0, and we have f of say a plus h minus f of a divided by h, right? And the notation for the right hand derivative may also be written as f prime, and here we write a positive sign, and here we have a, right? So if we have a function, say y is equal to f of x, and if we are given a point, say x is equal to a, then the right hand derivative of this function at x is equal to a is defined by this limit, that is limit h tends to 0, f of a plus h minus f of a divided by h. And the left hand derivative is defined by this limit, that is limit h tends to 0, and we have f of a minus h, and then we have f of a divided by minus h. And here we can write f prime, and we put a negative sign here, and here we have the point x is equal to a, right? So let us first find out the right hand derivative of this function. So here the function is given as e raised to a mod of x minus 1, and the point a is given as 1. So the right hand derivative is given by limit h tends to 0, and we have f of 1 plus h, and then we have f of 1, and here we have h, right? So now f of 1 can be calculated separately, so we can write f of 1 by replacing this x by 1. So we have e raised to mod of 1 minus 1, so this is e raised to mod of 0, and mod of 0 is 0, and e raised to 0 is 1. So f of 1 is 1. So we can now write limit h tends to 0, and we have f of 1 plus h. So f of 1 plus h can be written with the help of this function by replacing x by 1 plus h. So we have e raised to mod of 1 plus h minus 1, and here we have f of 1 is equal to 1 and h, right? Now this one and this one get cancelled, and we have limit h tends to 0, e raised to mod of h minus 1 over h, right? Now see, this quantity h is infinitesimally very small, and it is a positive quantity, right? And mod of h is equal to h. So we can now write limit h tends to 0, and e raised to mod of h is simply e raised to h, and here we have minus 1 and h, right? Now this limit is a standard result in limits, right? That is when we study the concept of limits, then we have a standard result in limits, that is a limit theta tends to 0, e raised to theta minus 1 over theta is equal to 1, right? So this limit is equal to 1. So using this standard result, right? So we can see that the right hand derivative of this function at x is equal to 1 is equal to 1. Now let us find out the left hand derivative. So the left hand derivative is given by this limit. So we have limit h tends to 0, and we have f of a minus h. So a is 1, so we have f of 1 minus h minus f of 1 divided by minus h. So now we can write this limit, that is f of 1 minus h. So f of 1 minus h can be obtained from here by replacing x by 1 minus h. So we have e raised to mod of 1 minus h minus 1, and f of 1 is equal to 1, and here we have minus h. So we can now write limit h tends to 0 and e raised to here this one and this one get cancelled, right? And we have e raised to a mod of minus h and minus 1 over minus h, right? Now see, a mod of minus h is equal to positive h, right? So we can write limit h tends to 0, and here we have e raised to h minus 1 over minus h. Now if we take this negative sign in front of the limit notation, we can now write minus limit h tends to 0 e raised to h minus 1 over h, right? So now again we can see that we have this standard limit. Limit theta tends to 0 e raised to theta minus 1 over theta is equal to 1. So this limit is 1, so we can now write minus 1, right? So now the left hand derivative of this function at x is equal to 1 is minus 1. So now we draw the conclusion, that is the right hand derivative is positive 1 and the left hand derivative is negative 1, and these two derivatives both exist, and these two derivatives are finite, right? But the right hand derivative is not equal to the left hand derivative, because plus 1 is not equal to minus 1, right? So we can conclude that this function is not differentiable at x is equal to 1, because for the differentiability of a function at a given point, say x is equal to 1, the right hand derivative and left hand derivative must exist, and they should be finite, and moreover the right hand derivative and left hand derivative should be equal to each other, right? So here we see that although the right hand derivative and left hand derivative exist and finite, but they are not equal, right? So 1 is not equal to minus 1. So we can claim that this function, that is f of x is equal to e raised to mod of x minus 1, is not differentiable at x is equal to 1.